If it takes 3.6 times 10 to the 5 joules of energy from 10 amps of current from a 120 volt source to boil water, how long does it take? So what this question is asking us is, you've probably done this in your life, you've plugged in your kettle, you know that something's happening there, some energy is being used, some electricity, and it takes a while for your water to boil. And so what we're looking at here is we're giving you the total. Well, how much energy does it take to boil this water? Well, we've got that here. And where's that energy coming from? Well, it's coming from some electrical source where we have 10 amps of current and 120 volt source. That's like what you'd plug into your wall. And so we want to know then, well, how long does this take to happen? So what we need to think about then is a couple of things. We need to remember that voltage and the work done, or able to do, is work divided by charge. And so we need to have charge in here somewhere. But in this example, there is no coulombs here, right? We have something different. In this case, we have current. And remember that current is a measure of your rate. So how much charge is passing by or through a wire or through a light bulb or whatever else in a certain amount of time. And so this is where the time is going to come in this question. And also from the current is where the charge will go into this equation here. So I can kind of combine these two things since Q is in both. I can write an equation for work here where we have the work that can be done is V times Q. And I can also say then that Q is, if I move this up on both sides, Q equals I times T. There's the current and the time. That would tell you how much charge, right? If it's 10 amps and it was 1 second, well, that would be 10 coulombs of charge. If it was 20 amps in 1 second of time, then it'd be 20 coulombs, so on and so forth. So this really gives us the total over this amount of time. I can replace this in here and get a formula for work that takes account current, and we get voltage times current times time will give us the amount of energy used in that time when there's a certain flow of charge. And since we have all these things, we have the work, we have the voltage, we have the current, we can rearrange this for time by dividing out V over I, V times I, not V over I. And we get a nice equation for time here where it is the work divided by the voltage times the current. And so to solve this problem, we will then put in the amount of energy used over this time, which was given. And we know that the voltage was 120 volts, the potential difference that this charge is moving through. And we know that it's 10 amps, or this is where, again, where the combination of time and charge come in. That's what current is just a moving charge and how much moves in so much time. And we get on the top 3.6 times 10 to the 5 joules, all divided by, on the bottom here, 120 times 10 is 120,000. And then some of the units will rearrange themselves here. Remember, voltage is joules per charge. This amps is charge per time, so on and so forth. And we get for time then 300 seconds or 5 minutes if we divide by 60. So that seems reasonable to me for the amount of time it takes to boil a certain amount of water in my kettle. If we want to look at the units a little more carefully here, we know that there's joules on top. Voltage is joules per charge, or joules per coulomb, times amps, which is coulombs per second here. And we're left with a fraction of seconds on the bottom, which moves it up. Joules cancel, coulombs cancel, coulombs cancel. And we're left with seconds, which was what we got as our answer.